It's Cambridge IGCSE for paper 4, theory extended for February-March 2024, and it's variant 2. Okay, let's go to the first question. Iron ore contains iron trioxide. A blast furnace is used to extract iron from iron trioxide. Equations for some of the reactions in the blast furnace are shown. Equation 1 shows the combustion of carbon in the blast furnace. Name the substance which provides the carbon for this reaction. That will be coke. And state the purpose of the combustion of carbon in the blast furnace, which is to provide heat, as coke is actually a fuel. Let's move on. Iron trioxide in the iron ore is converted to iron when it reacts with carbon monoxide in a blast furnace. Calculate the percentage by mass of iron in iron trioxide in Fe2O3. So percentage by mass of iron is the mass of iron divided by the mass of iron trioxide. So that times 100%. So you have to use your periodic table. And there are 2 iron atoms here. So it means that it will be 2 times 56 out of 2 times 56 plus 3 times 16 multiplied by 100%. And that gives you a total of, let's see, 160 is the mass of iron trioxide. And then 2 times 56 is 112. So 112 over 160 multiplied by 100%, that gives you a 70%. All right. For 2 marks, right? By the way, it's given to you for the total mass of the iron trioxide, molar mass of iron trioxide, and also the mass of iron. Okay, let's move on. State the name of the iron ore which contains mainly iron trioxide, the iron ore which is hematite, and describe how carbon monoxide is formed in the blast furnace is by well, reduction of carbon dioxide. Because it's carbon dioxide that reacts with more coke that leads to the formation of carbon monoxide. All right, that leads to the formation of carbon monoxide. So it's not an equation, but the carbon dioxide reacts with more coke, forming 2 carbon monoxide for each carbon dioxide. Okay. So you can also say that it can be due to, well, it can be due to, or should I say, just say that it's by reduction by carbon of carbon dioxide, if you want to add on the information. Right? Okay. Number 4, write the simple equation to show the reaction that occurs when iron trioxide is converted to iron in the blast furnace. So iron trioxide is reduced by carbon monoxide, forming your pure iron, and then carbon dioxide. So that actually involves 2 iron, 3 carbon, and then altogether 6 oxygen. Okay. Let's move on to the next question. Name the chemical process which happens to iron when iron trioxide is converted to iron in the blast furnace. There's actually a redox reaction, right? Redox reaction as of this is a redox, right? It's like or should I say, if you don't talk about iron, right? Wait for a second, because you're referring to iron. Let's just call it reduction, because the whole equation is a redox reaction, but the iron itself is undergoing reduction. Okay, then state the type of reaction shown by equation 2, that's thermal decomposition. Thermal decomposition. Okay, let's move on. Explain why the reaction in equation 3 can be described as an acid-base reaction. So equation 3 here is an acid-base reaction, as calcium oxide is a base, whereas silicon oxide is an acid. Okay, metal oxides tend to be basic, and then silicon, what we call it, non-metal oxides, or should I say semi-metal oxides, tend to be acidic. So as this is a base, this is an acid, so they together, they react, it's considered a acid-base reaction. Okay, state the chemical name for silicon 4 oxide. Okay, silicon 4 oxide. And then the common name given to calcium silicate. Okay, this is known as slag. This calcium silicate when it is formed in the blast furnace. Next, aluminium cannot be extracted from its ore using the blast furnace. Why is it not extracted from its ore using a blast furnace? Because aluminium is more reactive than carbon. It's right. Yeah, it's like aluminium is due to aluminium is more reactive than carbon. So it couldn't react. If you take aluminium oxide with carbon that will fail to react, name the process use to extract aluminium from its ore. There will be electrolysis. Let's move on. Both iron 3 oxide and aluminium oxide contain metal ions with a 3 plus charge. Write the electronic configuration of an Al3 plus ion. So aluminium, if you look at the periodic table, the atom has a 2A3 electronic configuration. Whereas if it turns to 3 plus, it donates 3 electrons, so making it 2,8. It is number of protons and electrons in an iron 3 plus ion. This one you will have to look at the periodic table. It's element 26, so 26 protons. All right. And then because it's 3 plus, so it has given out 3 electrons, making it a remainder of 23 electrons. Okay, let's move on. The elements in group 7 of the periodic table are known as halogens. Halogens can form halide ions. Identify the halogen with the lowest density at RTP. So lowest density halogen would be fluorine, because going down the group, the density will increase. State the appearance of bromine at RTP. So it is actually a brown liquid, bright brown liquid. Okay, now use the periodic table to give the symbol of the halogen with the highest atomic number. That I believe will be tennessine. So the symbol is TS. Okay. He used the number of occupied electron shells in an atom of this element. Okay, number of occupied electron shell refers to the period, right? Period 1 has 1 shell filled with electrons, period 2, 2 shells with electrons, 3 for period 3, and so on. So if you look at tennessee's position, it's period 1, 2, 3, 4, 5, 6, 7. It's period 7. So 7 electron shells occupied with electrons. Okay, bromine molecules have covalent bonding. State what is meant by the term covalent bond. It's a pair of electrons shared by between two atoms. Two atoms share a pair of electrons. Okay. Name one halide ion which bromine molecules can displace. That would be, well, based on the periodic table, bromine is more reactive than iodine. Reactivity decreases down the group. So it will be iodide that can get displaced, all right? Halide ion, you call it iodide, you don't call it halogen, you don't call it iodine, you call it iodide. So explain why bromine can displace the halide ion, because bromine is more reactive than iodine. Okay, name the halide ion that can be used to detect the presence of water. So halide ion that can be used to detect the presence of water is actually your cobalt-2 chloride. Cobalt-2 chloride is actually a blue chemical, like anhydrous form is a blue chemical. All right, anhydrous form is a blue chemical. It can be hydrated to form a pink solid. All right, the hydrated form. All right, which contains water of crystallization, the 6 of them for each cobalt-2 chloride in the hydrated crystal, and it's pink in color. Okay, so wait, allow me. Actually, the full name we should call it anhydrous form. If you want to be more precise, right, anhydrous form will be more accurate. You can't just use hydrated cobalt-2 chloride. You have to use anhydrous cobalt-2 chloride. Okay, next, calcium chloride is an ionic compound. Complete a dot and cross diagram for the ions in calcium chloride. Give the charges on each of the ions. So calcium is 2882, this is a periodic table. When it turns into calcium ion, it is 288. Whereas for chloride, chlorine is 287, chloride is 288. So you have to draw for everything 288. Whereas calcium is group 2 form plus 2, sorry, in the middle. Then our chloride is -1. You have to draw a 4 outer shell for the third shell. And essentially you have to draw 8 crosses for the metal ion to show that it's coming from the calcium. And then the dots are from the chlorine atom, and then it gains 1 electron from the calcium atom. Okay, let's move on. Aqueous lead-2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead-2 chloride is formed. Name a lead-2 compound which can be used in this reaction. So you want to use a lead-2 compound to make this. You have to use a soluble lead-2 compound. Popularly, we use lead-2 nitrate. Nitrate salts are soluble, so we like to use nitrate. Write the ionic equation for this fraction, include a C symbol. So aqueous lead-2 ions mixes with aqueous chloride ions, turning into an insoluble precipitate, which is lead-2 chloride, and 2 chloride ions to balance the equation. Name one other insoluble chloride, that is silver chloride. You have to know that this is actually a white precipitate. It's a chloride ion test. Let's move on to the next part. This question is about acid, bases, and alkali. Table 3.1 shows the pH value of some substances. Define the term base. Base is a proton acceptor. State what is meant by the term alkali. It's a soluble base. All right. Thermopylae is an indicator. State the color of thermopylae in sodium hydroxide and also ethanoic acid. Thermophthalate is blue in alkali, colorless in acid or neutral solutions. Let's move on. Use the information in the table to identify the substance with the highest concentration of hydrogen ions. Explain your answer. It will be a strong acid. We have to identify a strong acid from the diagram. That will be your nitric acid. So, nitric acid. Why? Because it has the lowest pH. Based on the table, it has the lowest pH. Name an indicator which can be used to identify the substance with the highest concentration of hydrogen ion. So you can use a universal indicator. All right, let's move on. Complete equation to show the dissociation of ethanoic acid in aqueous solution. Okay, given that this is a weak acid, right? It will partially dissociate, partially ionize in water to form low concentrations of hydrogen ion and also leaving behind an ethanoate ion. Okay, so it's a reversible reaction, right? It's an equilibrium where the mixture contains all the reactants and products existing in equilibrium after the dissociation is completed. Okay, so the 3 marks are awarded according to hydrogen ions, ethanoic ions, and also the reversible symbol. Okay, write the ionic equation which represent a neutralization reaction between any acid and any alkali. So every acid and every alkali has this ionic equation, hydrogen ions reacting with hydroxide ions forming water. Okay, next, dilute nitric acid reacts with aqueous calcium hydroxide as shown. 20 cubic centimeters of 0.015 molar calcium hydroxide reacts with 25 cubic centimeters of nitric acid. Calculate the concentration of nitric acid in gram per cubic decimeters. Calculate the number of moles of calcium hydroxide used. So that would be 0.015 20 out of 1,000. Make sure you convert this to cubic decimeter first. Multiply by concentration 0.015. Compute this out in your calculator. And you should get 0.0003. Yeah, 0.0003 moles. Next, determine the number of moles of nitric acid which react with calcium hydroxide. So, based on the mole ratio from the equation itself, you see that nitric acid react with calcium hydroxide in a 2 to 1 ratio. So if you use 0.0003 moles of calcium hydroxide and reacting with nitric acid, this will mean that nitric acid has a 0.0006 moles of nitric acid is used. And let's move on. Calculate the concentration of nitric acid in mole per cubic decimeters. So nitric acid, so you just divide by the volume. To find concentration, simply take the mole divided by volume. So 0.0006 divided by 0.025. And punch this in your calculator. You get 0.024 mole per cubic decimeters of nitric acid. Let's move on. Calculate the concentration of nitric acid in gram per cubic decimeters. So we have the mole, we have the units in mole per cubic decimeters. That's the concentration of nitric acid. To find out the concentration in gram per cubic decimeters, you will have to multiply by molar mass because molar mass has a unit of gram per mole. So what's the molar mass of nitric acid? Which is 1 plus 14 plus 16 times 3. Mix it all together, 63. So times 63 multiplied by 0.024. That makes 1.512. All right, 1.512 gram per cubic decimeters. Okay, that's it. Let's move on. The equation for the reaction between methanoic acid and ethanol in the presence of catalyst can be represented as shown. X represents the ester form. In this equation, methanoic acid is represented by the formula HCOOH. Name this type of formula. That is the structural formula, right? Structural formula, because it shows you the structure of the chemical. Write the empirical formula of methanoic acid. Just CH2O2, because you can't really simplify it further. Okay, name and draw the displayed formula of ester X. Okay, so you are having methanoic acid and ethanol. You will form ethyl methanoate. First name alcohol. First name is derived from alcohol, ethyl. Next name is derived from the acid, so methanoate, ethyl methanoate. So given that's the case, and you have to know that this is a condensation reaction, meaning you will remove a water molecule. All right, remove a water molecule as shown here. So after deducting that, after taking away water, you're left with the methanoic part plus the ethyl part. And also know that, allow me to draw your ester linkage, which is C double bond OO. Okay, the reaction is reversible and reaches an equilibrium within a closed system. See what is meant by the term closed system. Nothing can leave or enter. See two characteristics of an equilibrium. So the rate, an equilibrium is achieved when the rate of the forward reaction is equal to the rate of the backward reaction. Which leads to the concentration of reactants and the concentration of product to remain constant. So let me draw a graph if you want to get the idea. An equilibrium graph can be represented as shown, where concentration time graph, the reactant and the product remains unchanged after a certain period of time. And this is due to, not because the reaction has stopped, but because the rate of the forward reaction and the rate of the backward reaction remains the same, which means that there is a same rate of reactant to product conversion and then product back to reactant conversion, which leads to the concentration remain unchanged. Okay, let's move on. Complete the table to show the effect, if any, on the concentration of X at equilibrium for each change of condition. So, okay, first of all, we don't look at the equation first. We just try to analyze the change of condition. Okay, temperature is in decrease means that it will favor the exothermic direction. This is increasing concentration of reactant, so you will increase product concentration. As X is a product, so you are increasing reactant concentration, that will lead to increase in concentration of product at equilibrium. Then concentration of both reactants are increased, so also increases. Wait, pause. Sorry, decrease. So it will decrease the concentration of products. And then catalyst is removed, doesn't affect you. All right, so no change on that, doesn't affect you. So you want to ask for decreasing temperature. Decreasing temperature will favor the exothermic direction, which is the forward reaction that causes the concentration of the product to increase. And that's it for this paper. No, sorry, there's another page. Oh, I mean 2 pages. Okay, more. Okay, butane and but1ene are colorless gases at room temperature and pressure. Suggests why but1ene diffuses quicker than butane. So because it has a lower mass, but1ene has a lower relative mass than butane. Okay. If you want to be more precise, it's like lower relative molecular mass. Okay, identify the products formed when butane undergoes complete combustion. So there will be carbon dioxide and water. As this is a hydrocarbon, as you know, hydrogen burns in oxygen to form water. This is shown in your hydrogen fuel cell. And carbon reacts with oxygen to form carbon dioxide. So having a mix of both hydrocarbons, you form both water and carbon dioxide. One molecule of butane reacts with one molecule of chlorine in the presence of UV light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. Name the type of reaction which needs UV light. So it's a substitution reaction. Or should I say, wait, actually pause for a moment. I think in terms of the wording itself, it sounds like it's a photochemical reaction. That sounds better. Photochemical reaction. Because it needs light. Okay, state the purpose of UV light in this reaction. So to provide activation energy for the reactant particles to react. Name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. This one we just say substitution. Okay, because of the wording, it sounds like this one is looking for the word photochemical, whereas this one is definitely substitution. Determine how many different structural isomers can be formed during this reaction. Oh, wow. Okay. Oh, am I overcomplicating this question? I think I am. Yeah, I'm overcomplicating. I was thinking of the whole reaction, like each hydrogen gets substituted, but no, it's just the first step. The first step. So the first step, right? It might be you might form one chlorobutane or two chlorobutane. So two structural isomers. All right. Allow me to draw it so that you can see. You have butane. Right, you have butane. Then you can form one chlorobutane or two chlorobutane. Two possible isomers can be formed. Structural isomers can be formed. Okay, when but1ene reacts with steam, two possible products can form. Identify the type of catalyst which is used in this reaction. This is an acid catalyst. Name and draw the display formula of the two possible products. So but1ene, let's draw but1ene first so that we can see the pattern. This is but1ene, right? But1ene. Draw the alkene, the double bond, carbon-carbon double bond, then only followed by hydrogen atoms. Okay, so there's two possible reactions that can happen here. Either hydrogen go to the first carbon, hydroxide, or should I say hydroxyl group goes to the second carbon, or the other way around. Okay, so in fact, let me copy this. Let's say I move it down like this. Open a double bond, form two new connections. Oops, actually I'm drawing it wrongly, sorry. So I'm missing a hydrogen. One is like this, which is one hydrogen, sorry, carbon 1 gets connected to a hydrogen atom, carbon 2 gets connected to the oxygen and hydrogen. Then you have the second product, which is the opposite, like this. Okay, so you get butane 2O or butane 1O, right? Butane 2O or butane 1O. Okay, but1ene undergoes polymerization. State the type of polymerization that but1ene undergoes, because this is an alkene. So it will be addition polymerization. Alkenes undergo addition reaction. Alkenes will undergo addition polymerization. Draw the part of the polymer molecule to show three repeating units. So but1ene, as we have drawn just now, okay, you must align it together. You must align it together to form a good, what we call it. Allow me to just wait. Allow me to show you everything first. This is but1ene. Okay? For an addition polymerization to be carried out, the other groups must align themselves to a different position, because it's the double bond that will be responsible for the polymerization. So we have to align it to the bottom. This one is C2H5. Let's move it down. C2H5. Let's move it down like this, and then you open the double bond, forming two single bonds, and they want three sections. They want three repeating units. So let's show them that exactly. That shall be your diagram. Okay, it will be 6 atoms joined, continuous bonds, by the way, right? Because it's just a section. And then you have the alignment correct. And then all are single bonds, of course, due to it has really undergone addition polymerization. And that's it for this paper. I'll thank you for watching, and then I'll see you in the next one. Bye-bye.